Okay, so we are the data enjoyers and we are looking at population trends in different continents. And specifically, we made models and predictions of these population trends using our machine learning models. We specifically looked at the different factors and forces behind our population changes, and we showed the importance of these factors on our growth as a population and our future through the use of different visuals. We also allow using machine learning models, we provided predictions of the future of our population and on these specific factors to help people achieve a deeper understanding of how they affect each other and how they affect us in our everyday lives. We provided some examples in the homepage of the models that of some of the visuals that we provide. In our website, we present different interactive visuals and models that you can input your own variables to see the trends that you are interested in, or just general information about these different factors like the history of fertility rates and stuff, as well as a bit of exposure for what machine learning is. We included our process, which models we chose and which ones we didn't, and why we didn't choose them, why they weren't good for certain factors. And an about us page just showing the coders behind the scenes and the people who made this project. We also had we also include different visuals like scatter plots, line graphs, heat maps, and choropleth maps, basically just to visualize some of the data to help get the idea across and help people see how different factors affect each other and different trend lines. And some of the models behind these visuals are like the polyregression model, which is just a form of regression analysis that uses the relationship between an independent variable and a dependent variable and is modeled as an n in the nth degree of polynomial curve. Support vector regression, which is a type of supervised learning algorithm that is used to predict discrete values and create a best fit line. Gaussian, a classification machine learning algorithm that is used to classify data in different categories based on the probability distribution, and lasso, which stands for least absolute shrinkage and selection operator, which is also a regression method that performs both variable selections and regulation to enhance the prediction accuracy and interpretation. In the homepage, we also included a quote from our mascot, which is very important. We go all the way up. The buttons under those two buttons, the get started and learn more, are just to help the users move around and get them moving in the direction of learning more about these factors. Yeah.
Okay, so on our background page, if you want to get a better understanding of what some of the terminology is, or just want to learn more about machine learning, here's the best place to go. So as of now, there are 7.753 billion people in the world. After reaching 2 billion in 1927, population growth has skyrocketed, which is reaching the next billion in just 33 years. There are so many factors that affect population growth, including fertility rate, mortality rate, median age, natural resources, economical, political, etc. And as of now, the population grows about 83 million per year, yet the factors individually show that the growth rates are slowing down. Why is that? Well, if you continue scrolling, you get a better glimpse on why, at least the main vocabulary. So in this section, you see 6 or so main vocabulary that is used throughout our website. And that is because in our interactive visuals, you get to actually select which inputs you want, and you may want to know what they are and why they're so important. So these 6 main vocabs are population density, fertility rate, median age, urban population, net migrants, and developing and /develop. And that's pretty neat. And if you continue scrolling, you see more information about each of these population factors. So if you want to learn more about what affects fertility rate in general, or what affects population density and median age, you can click down these accordion dropdowns and see more information. Or if you just want to know more about machine learning, such as confidence intervals, training and testing a machine learning model, which we'll get to a little later, you can do so as such. And
Did I click the wrong one? That's my bad.
Yeah.
I'm so sorry.
Alright, it looks like some of our images on this page are not currently working, so I apologize in advance for that, but I'll just go through the other material that we have on the page. The purpose of the About page was simply to better express our reasoning behind this project and how we achieved this project. You can see that on the top of the page, we described why and how we achieved this project and why we chose this project. Our main goals with this focus for our project, population trends, was to relate population trends between countries and continents and gain a better, deeper understanding of all the different population factors that can greatly increase or decrease population and get a better understanding of how these will change in the future. So we achieve this by using visualizations as well as a variety of machine learning models to evaluate the importance of different factors and their relationships with each other. So the first stage of our project was data analysis. For this, we found our datasets on Kaggle, and then we analyzed these datasets using Python and Pandas. This was a very interesting experience, and we were able to encounter a lot of different datasets. Some of the datasets that we used are listed below here. The main ones were world continents, 25 most populated countries, and also women in labor force. And we were able to explore the relationships in these various datasets. The next part of our project was machine learning. Here we basically tried to use our data to train accurate machine learning models. We looked at a variety of different models to find the ones that would be the best fit for our data, and we settled on using the SVR, or support vector regression, lasso, polynomial regression, and Gaussian regression. We imported these from scikit-learn and then trained these models. These allowed us to have pretty accurate predictions of future population values. And we have an About Us section, our team. This is all of the wonderful students I was able to work with to create this project, and we just wanted to include some information about us.
Now we're on the interactive visuals.
All right, so this is one of the main parts of our website, all of our visuals that we made, including the interactive ones. So you can see our first visual is the heat map, specifically of the USA. And this demonstrates the strength and correlation between certain factors within a data set, and which was the 25 most populated countries. And this is important because with the heat map, you can see what two factors are correlate the strongest or what are not. And you can see that if there's a negative one, which means there's a negative correlation, meaning as one goes up, the other one goes down. Or if there's a one, meaning that as one rises, the other one also rises. Direct correlation as such. And it was pretty important because from this, we could see that median age and fertility rate had a negative correlation or negative, close to a -1 on the heat map as such. So if you continue going down, you can see a simple line graph that shows the continent population trends of the 6 continents, excluding Antarctica. And this is important because this is one of our first visuals that we use. And it was like a stepping stone to help us understand the different relationships in the data. And as you can see, the Asian population is way above all the other continents, which does make sense given the past history and how it's the most populated continent. Now here's if you continue scrolling, you get to see the fun main interactive model in which you can input different factors and see how they're related to each other. So for instance, you can input a dependent factor such as median age and choose a relation factor such as fertility rate and see how it looks. So the dependent factor will be on the y-axis, while the relation factor would be the different sizing of the data plot, data points. And that's important because then we can see how 2 different factors or variables affect each other, as you can see as such. And here's a fun bonus. We use a chlorophyll map of the female labor force participation rate because the more females that work in the labor force, the less fertility rate, the lower fertility rate goes because if more females are spending more time working and not having enough time to take care of children, they will produce less children. And if you select different years from 1990s all the way to present, you can see how as more continents have more women working, the lower the fertility rate goes, and you can check that on the scatter plot above. And our last model is a quick shift from continents to the populated countries. And within this 3D scatter plot, which you can obviously move around, we used this to see the relationship between different population factors within the countries and visualize the relationships within time. So like if you select a country, let's say China, and then choose one factor fertility rates and another one as density, you can see how the different data points in the 3D model shift around, and you can kind of see some trend going on over there, which is pretty neat.
Our next page is about the machine learning models we used. So like I described briefly earlier, our objective with these machine learning models was to gain a better understanding of the various population factors we explored through our data and predict their values in the future, so we could understand how they could affect different people in different locations. So we have, using the button view our models, you can go and look at our various models. Our first one is the Gaussian regression model. Pictured above is like a sample graph that the model produced. We decided to utilize this model since it works well with smaller datasets, as most of our datasets were relatively small. As you can see on the graph, the orange border is the 95% confidence interval. So that displays how certain our machine learning model was of its predictions. We also have some metrics below that allow you to see the effectiveness of our model. Since the MAE is pretty close to the standard deviation, we decided that this was a good model to use. We also realized that looking at some of our other models, the differences between standard deviation and MAE were smaller, making them potentially better models to use with our data. So if you continue scrolling down, our next machine learning model that we used is a lasso regression model. So we created a 3D scatter plot to visualize the difference between the actual data points and the predicted data points from the machine learning model. So you can see that they're pretty close, so this ended up being a pretty good model for us to use for our data. The lasso regression model is actually related to a linear regression model, and that made it really good to use for our data because we had some really strongly correlated factors, as you saw in our heat map earlier. We also have some metrics down below. As you can see, the MAE is a lot smaller than standard deviation, which meant that this model was pretty effective at predicting future values of our data. Moving down, we also tried looking into the support vector regression model, or the SVR model. Once again, you can see the difference between actual data points and predicted values. Although this model didn't work quite as well as the lasso regression model, it still worked pretty well, especially as time went on. You can see that the divergence between the two different colors decreases a bit. So this was definitely a great model to use for our data. The last model that we used was a polynomial regression model. We used this model to predict fertility rate for Africa, since that wouldn't follow a linear path and would better follow a polynomial path. So this model was able to accurately predict future fertility rates for Africa until around 2060, but as you got further into the future, the predictions from this model got less accurate since it didn't follow a perfect polynomial graph path. So we could have used other models to more effectively predict further into the future, but this model was able to have pretty accurate predictions for a limited amount of time. So the last page that we made was an FAQ page. We wanted to explore some of the questions that would come up about our process and just the different difficulties that we faced. So our first section here is roadblocks, and we have a couple of questions that we discussed as a team. Like, this was a pretty awesome program, but it was also the first time a lot of us were encountering these concepts in code. So it was definitely interesting to learn through that and also connect with each other as a team. So we just wanted to show some of that story in our website as well. And below that, we have a machine learning model section. That just goes more into depth in our selection process for our models, because we explored a lot of different models and eventually settled on a couple that we felt would best fit our data. So we also discussed some models we ended up not using, and overall this FAQ page just is an overall conclusion and summary of our process during the project. Thank you so much for listening to our presentation. Please let us know if you have any questions in the chat.